Hi, welcome everyone. This chapter is going to go over methods, specifically how we conduct research, how we use different tools, techniques, and applications to actually collect data, and how we just kind of go about looking at psychology from a scientific and a research-focused perspective. All right, let's go ahead and dive in. In this chapter, we have a few different learning objectives we're going to talk about. We're going to start off by talking and explaining through how scientists or psychologists use the scientific method in the study of psychology. We're also then going to look at some different specific ways that we measure behavior or collect data, looking at things like natural observation, surveys, case studies, things like that, and talking about these different techniques and some pros and cons to each of them. Then we'll talk a little bit about ethics and how we use ethics in psychological research, some of the principles that we have to make sure we abide by, and ways that we sort of focus on maintaining ethical standards in our research. Then the fourth one we'll talk about is talking about research in terms of correlations. So we're going to see that correlations have a very specific use in research, and how we use them is important to make sure we're using and interpreting them in the correct way. Then we'll also talk about, on the other hand, experimental research. And so experimental research is used to answer different types of questions than correlational research is, and we'll compare and contrast kind of those two different types of things. And then lastly, we'll talk a little bit about how we actually look at numbers and data itself in terms of kind of discussing sort of the central tendency and how we use these different techniques or approaches to measure the actual numbers within our data. All right, so let's start off with our first learning objective, talking specifically about how we use the scientific method in the study of psychology. All right, so I love this quote here, and I'll go ahead and read it real quickly for you. But at some time or another, everybody asks the questions: why, what, how? The child asks, where do babies come from? Parents ask, why does he believe or behave like that? Samuel Johnson remarked that curiosity is one of the permanent and certain characteristics of vigorous intellect. So the scientist might be defined as a person whose indulgence of his curiosity is also the means by which he earns his living. And so I like this quote a lot because as sort of a researcher and a scientist and someone myself, I agree. Really, all we do is we ask questions, things that we're curious about, we want to know the answers to, and well, that is our job, and that's how we make a living. And so we get to sort of just indulge our curiosity and measure things and try to find answers to the questions that we have, and that is our role and our job to do so. So making sure we do it in a controlled and specific way is important. And we're going to talk about that as we get into the scientific method. So when we talk about this idea of how do we know things, so when we ask these questions, we might have ideas or specific hypotheses as to what we think the case might be. But once we test those hypotheses and we engage in some type of study, we may or may not find support for our initial thoughts or predictions as to how these answers might appear. And so I love this example here. If anyone isn't familiar, we have sort of this overarching sort of top-down view of the famous Milgram study. So the Milgram study looked at basically obedience to an authority figure. And in this study, the participant was told to continue administering electric shocks to some learner that was answering questions. And if they got the question wrong, the participant was told to administer an electric shock to them. And they had the experimenter, who was sort of the scientist in charge here, was the person telling the participant, this is the participant, to administer these electric shocks to the learner here. And the learner was also an experimenter. So this is not a real person. Only this one is the participant. And, the idea was that people would stop. The idea here is that we would expect participants not to continue administering electric shocks as they went. And so what's really interesting is that's not what they found. They actually found that participants were, a good portion of them were administering higher and higher electric shocks. And that's not what researchers expected, but we saw sort of this strong effect of obedience to the authority figure telling them to continue doing this. And what's so interesting about this study is that, well, a couple things are interesting about it. Number one is ethically, it's not something that we would be able to do today, nor would we want to. But back before sort of they identified some of these concerns, this is something that uncovered this idea of obedience and an unexpected result from what the researchers originally thought they would find. And so this really just highlights this idea of this process in thinking we have some answer or having some prediction, some hypothesis, testing that, and maybe finding support for it or not. And so we're going to look through kind of what this process entails and talk about how we can test things in a way to get accurate answers and whether our answers are correct. So when we break down the science or the psychological principles in terms of the scientific method, we can kind of look at each of these steps along the way. So first we identify a problem or some question that we might have. Then we have to gather information on that. So what is already known about the topic? What can we build off of? We generate some hypothesis based on the knowledge or the information on the topic. We design some experiments, some study, something to test that hypothesis and see if we find support for it. And then we analyze those results and determine whether or not we do in fact have conclusions that support our hypothesis. And one of the sort of interesting points here that I think people often leave out or forget about is that there is this sort of repetitive process where we're going to reiterate on what we've done. And so if we find support for our hypothesis, great. We can test it again and make sure that it is robust and that we see it in other contexts. If we didn't find support for our hypothesis, well, then maybe we have to revise our hypothesis and test a new prediction or a new theory based on that. So let's kind of keep going here and see kind of how these steps work. So step one, identifying the problem. So let's look at this example where maybe our problem or our question based on some observation that we might have observed in the world or in the environment. And so this research question here is, under what conditions will students come to class prepared with completed activities? So we give out activities and we want students to complete them before they come to class. Well, let's see how we can test this question and how we can build on this. Well, first we have to gather information. We have to see, okay, what is it that students are already doing? Are they preparing and coming to class, or are they not preparing before they come to class? And so let's say we find out that about 70 to 80% of students do not prepare before coming to class. Well, that's an interesting statistic, that's an interesting number, and that provides rationale for this test and for this study to try and understand what we can do to help students prepare before coming to class. So the next step is develop some hypothesis. Well, maybe our hypothesis is that if we test students, if we have some type of assessment that they will have to perform, well, they're going to be more likely to prepare before they come in to class. And so we might create two different groups or two different, situations within our study where students might be required to complete some assessments for points, for a grade, and then maybe some students who are not required to complete assessments for points. And we expect that those who are required to complete them for points are going to lead to them being more likely to prepare for class versus those that don't. So now we have a hypothesis. So what can we do with this? Well, we need to design and conduct some experiment to test this hypothesis. So maybe our experiment is that we give out some readings before class, and then we have students take a quiz at the beginning of class based on those readings. But in order to test our hypothesis that the points, that the assessment, the value in these quizzes are what drives students to prepare, we need to create multiple groups so we can compare between our two groups. So in this case, we might have an experimental group where students are earning points for taking the quiz that's actually going towards their grade, and then maybe a control group where students don't earn points. They don't get any grade for the quiz, they just take it for fun. And then we compare the two groups and we see, are they different? Do we see more preparedness in the experimental group because they knew it was counting for points versus our control group? And so now that we have our study designed, well, we conduct it and we collect data, we separate out our groups, our variables, and design our study in the way that we'll be able to answer our hypothesis or answer our research question based on our hypothesis. And then from there, again, we get some data analysis and draw some conclusions. We analyze and maybe we see that, well, yes, maybe more people are doing better on quizzes and because they are preparing for class when the quiz counts for points. So we see higher grades, we see more preparedness when that quiz counts for points than when it doesn't. And that's our result, and that supports our hypothesis, right? And so as we kind of go through, we see our conclusions in this case might support our hypothesis. But again, things don't stop there. Just because we find support for our hypothesis doesn't mean we can't still reiterate on it or we can't build off of what we'd found. And so maybe we need to look at how this applies in other contexts, in other classes. Maybe we want to say, okay, great, this worked in one class. Let's see if it works in another class. Or maybe there's something unique about this one class that made this work. Or maybe it works for some students, but not for others, right? Maybe some students already have a very high grade. And so, doing well on this quiz is not as meaningful to their overall grade, or vice versa. So we continue iterating on this. We don't stop. We build off of previous knowledge and previous research to continue the process of understanding and uncovering just the information and knowledge about how these things might work. All right, so that really wraps up the first learning objective, talking about the scientific method and how we use that. So let's get into our second learning objective here, where we're going to look specifically at some different ways of assessing information and how we collect data using different methods. So the first method I want to talk about is naturalistic observation. So in this method, we're really just observing people in their natural behavior, their natural environment, and trying to understand sort of why they're behaving the way they are, denoting sort of what actions they might be taking, and comparing that to some knowledge that we might have. So a few key points about this one in specific is that for naturalistic observation, there's some limitations, right? We don't have control over the environment. We don't have control over what participants may or may not be experiencing. We're just really observing and trying to take note of what's happening. We also normally don't look at control groups because, well, we don't really have experimental groups that we're manipulating. And so while naturalistic environments are great at uncovering and understanding how people behave in their true environment, it's harder, or some of the drawbacks are that we have less control over sort of the manipulation of things. And so these are definitely pros and cons, and there is value to naturalistic observations, but there are challenges in using them to answer certain types of research questions where we might need or want more control when we are performing those types of studies. The next one, which is a really kind of interesting one, is participant observation. So in this type of way of collecting data, or just observing participants, this is really the idea of like going undercover, if you will, right? So in this one here, we're really kind of looking to become a participant, or sort of like, ingrain ourselves into a particular group and collect data, collect information as being part of that group. And so again, you can see maybe how this might be useful to uncover certain, characteristics or features of that group that may not be shared as easily or readily when it's more, conscious in nature. So maybe you're able to interpret things from the group because they, view you as an in-group member. They trust you. You can glean information a little bit differently than if we were to ask people to answer these questions on, say, a survey or something like that. People might just be more open, more honest in their own sort of group. So this is a really interesting one. It's not as common of a tactic, but it is one that does provide some unique perspective on trying to look at data and observations. Then we can talk about case studies. So case studies are a type of, observation that is one that we use fairly often, or at least in very specific cases, and it collects and it provides a lot of information, honestly. These are really useful to get information about a very specific thing. And so what's interesting about case studies is that oftentimes these are when we just observe one unique individual, and that individual has some characteristic about them that makes them an interesting person to study for a particular reason. We'll look at one here in a second. But normally this is that, these participants might have some individual characteristic that allows us to get unique, specific information that doesn't apply to the general population. So what I mean by that is, let's look at this one. So patient Henry Molaison, or HM as he's abbreviated, was someone who had particularly difficult challenges in memory and remembering. And so what they were able to do was to actually image HM's brain and look at how this one individual structure of this person's brain compared to the normal or average brain of many other people. And so what they uncovered is that this person, had some unique characteristics about their hippocampus, which we know now has to do with memory. And we could see those individual unique characteristics of HM's brain and the behaviors or the unique sort of outputs that they were, behaving as, and draw that direct link to those two things because of the uniqueness of this one individual case study. And so often what we kind of do is we look at case studies as an initial way to understand what might be happening or what might be explaining what's going on. And then oftentimes we can sort of confirm this or provide additional evidence through other means to kind of bolster our theory even farther. But case studies, again, offer really unique insight into individual characteristics that maybe only one person has, but we can draw general conclusions about. And then, of course, we have surveys. So surveys, I'm sure many of you are familiar with this idea, right? This is just the idea that we might ask people questions on a survey. And this is probably the number one way that we collect data, especially in psychology, because, well, there's a few different reasons why. Number one is it's generally pretty easy to do. It's pretty straightforward. Oftentimes we can list out lots of different information and get participants to report that information in a really just efficient way. Of course, there are drawbacks or limitations to surveys as well. Participants may or may not be accurate in their assessment, whether that is intentional or unintentional. Maybe they just aren't good at assessing themselves in certain features or characteristics, or maybe they deliberately want to report themselves in a better, more positive light or some other nature. And so surveys have their limitations for sure, but they're a great tool that we use in a lot of different contexts and a lot of different areas of psychology. And we'll see sort of how that kind of plays out, especially as we kind of go throughout this semester. All right, so that wraps up the second learning objective. Let's talk now about the third learning objective. We're really going to kind of focus a little bit on ethics and how ethics really kind of plays a crucial role in our methods of research. So ethics is really important, and it's something that has evolved over time. What I think is really cool about ethics is it's basically agreements by a society on what is right and what is wrong. And they change throughout the years. They change based on cultural norms, based on, the times. And it's really just this idea of what we as a collective group agree is right and wrong and okay and not okay to do. It's the same idea with morals, whereas morals might morph and change from one society to another, one time point to another. We see the same idea here in ethics. And not only that, but we also have seen a resurgence, or I should say more of a increase in the focus on ethics and how we design our research to make sure that we're incorporating ethical standards as we go. So let's talk about some of these. So the definition of ethics, right, just a set of general principles of how people should be treated, educated, and respected when participating in any study. So when we talk about ethics, there's a few main principles that we need to make sure that we adhere to and that we abide by. And these are kind of documented and listed in this sort of organized way. And they're ones that we kind of take into account in all of our research. First one being beneficence and non-malfeasance. This is generally just the idea you should do no harm, right? So We should not be hurting participants for no reason or really in general, and just you should be striving to do good. Principle B, fidelity and responsibility. Again, making sure that what we are doing in our research is responsible, that we are, sort of integral in our own study and in our own data, and that we are, again, reporting and demonstrating things in a responsible way. Principle C, integrity. Pretty straightforward on that one, but making sure that we have integrity in our research, both in what we report, that we are reporting accurate results, we aren't manipulating data, and also in how we're treating participants. Principle D, justice. This is actually a really interesting one, which might sound just like what it is on the surface, but really justice has more to do with how people benefit from research. And so this is a really interesting piece of ethics in research. And when we talk about, which we'll see in a second, when we talk about who we select for our research, who the participants in our studies actually are, we need to make sure, this principle of justice, that those participants, or at least the population that they come from, are people who can benefit from the research that we're doing. So a great example of this that I like to talk about is if you look at inmates, so people who have been incarcerated or in prison, they have unique specific protections put on them for participating in research. And there's a few reasons why, but one of the reasons here is justice. And so let's say you want to do a study on, I like throwing out the idea that you want to do a research study on which type of phone people tend to like better, iPhones or Androids. And you say, well, let's get inmates, let's get people who are in prison to be our participants because, well, they have this unique perspective that they have not used either phone because they've been, incarcerated for X number of years. And so they can offer this sort of clean slate perspective. And while that sounds great on the surface, what you'll find is that, let's say your research reports results and your outcome tells you that, well, people really like iPhones better. Well, that's great. What do you do with that research? What does that provide, and what does that benefit people with? Well, maybe that benefits the design of Androids, and they change things to make those better for people to be able to use them better and are happier with them. And while that's great and that benefits people who are using these phones, it provides no benefit to the actual people that participated in your study because they maintain their incarceration and they're not going to be able to use these better phones that you designed. So this is really this idea of justice. Who's participating in your research should, at least from a large scale group, be able to benefit from the knowledge gained from your research. And then the last one here is the respect for people's rights and dignity. That one's pretty straightforward. Again, just making sure that we have things like, informed consent. We have, we are treating people with respect. We are not breaking confidentiality and things like that. And so when we look at this idea of ethical principles, well, that's great. We have these ideas, these standards that we abide by, but what is keeping people within this checks and balances, or what makes people actually adhere to these? Well, these are what are known as institutional review boards, or IRBs. And so these are groups that operate inside of large research institutes. So we at UCF have an IRB, and they are responsible for evaluating any research that is done at that institute. So if you or I wanted to conduct a research study here at UCF, well, we would have to submit an application of what our research study is going to be. We'd have to go through this process with the IRB where they review, they ask us questions, they make sure that our study is all, ethically sound. And once they have reviewed that, then they approve your ability to do the research. And so these IRB boards are really an important piece of ensuring that ethical research is maintained and that we abide by these principles. Because oftentimes, you could even set out with the best intentions, but forget some piece or miss something that you really should or shouldn't be doing. And this is sort of another group that is there to help be able to assess your research and make sure that we're all abiding by these ethical standards. So this is a really interesting example, or a really interesting study that was done that kind of brings up some debate in terms of how much ethical consideration went into this. So this was the Facebook emotional contagion experiment. And so in this experiment, researchers basically took or they manipulated how many positive or negative news feeds people were seeing on their Facebook page or on their Facebook feed. And there was about 689,000 people that were in this study, but none of them knew they were in the study. None of them provided informed consent, saying they agreed to be in the study. None of them had a chance to withdraw from the study. They were unaware that they were in the study. And so what's really interesting here is I think you can kind of see, like, is this okay? Was this okay to do? And maybe not. You might be able to make the argument that, well, no harm actually came to them. It was just news that would be shown to them one way or the other. And I think most people kind of take away from this that this really isn't okay to do, right? This isn't doing this research, manipulating people in this way without their consent is not an ethical standard in terms of research. And what's really interesting here is we can draw parallels between this and, say, like algorithms on our different social media feeds. And are those algorithms doing really anything different than they did in this study? And I think in a lot of ways the answer is no. And so, I think this idea of ethical research and practical, maybe business standards is a little bit of a blurry line that we might need to be aware of at least. So. And then, like I said, there are certain populations, certain groups of people that have special ethical considerations. So the one I mentioned before were inmates, right, who have much less availability to benefit from research, but also people under the age of 18 are a special population. Oftentimes pregnant women are also considered a special population. And these different groups of people are not considered able to give what's called informed consent, right? So they are special protected groups that cannot provide informed consent and may or may not have to have informed consent given to them, given for them in different contexts. So the most common context you might see this is for research with children. And so children are not considered old enough to give their own informed consent. So a parent or guardian might have to give their own level of informed consent. And all that is then required of the child themselves is what's known as assent, which is just generally their agreement to participate. So when we think about these two things, we think about informed consent is something that people can give when they are aware of all of the possible harms or benefits of what they're agreeing to or signing up for. And assent is just the general agreement that, yes, I will do this. So the argument here is that children may not be able to understand the full degree to what this means, participating in research, what are the harms or potential benefits that might incur to them. But they can still give their assent, meaning that they're not screaming and kicking and trying to get out the door. And so if they don't have assent, just agreeing to participate in general, they're probably also not going to be able to be a participant in the research. So both of these two things, again, often in children, are required to kind of be considered an ethical participant. We also should talk here a little bit about deception. So deception is a crucial kind of tool that we use in research a lot of the time, but does hold with it some very specific ethical considerations when we are when we're using it. And so a couple key things that often have to be done here. Well, first and foremost, deception might just be necessary, right? If deception is necessary because you need to, say, not tell a participant about something you are trying to measure because that's what you want to measure, and you don't want them to change that aspect about themselves because they know they're being assessed on that. So deception is oftentimes a necessary piece to include, but when it's not necessary, it really shouldn't be included as well. But when we do use deception, a couple key components that must be adhered to are things like debriefing, where we explain what was used at the end of the study. And then also sometimes just being able to kind of explain why the deception needed to be incorporated in the first place. So deception, again, sometimes is necessary, but it is important to debrief and eliminate any deception at the end of the study. All right, so that wraps up our third learning objective. Now we're going to switch over to our fourth learning objective, and we're going to talk here specifically about correlational research and how we kind of use that, what it means, and how we can interpret correlational research through some graphs and things like that. All right, so we talk about correlations. I think this is a very common way of looking at comparisons and looking at how two relationships or how two variables might have a relationship with one another. We see this a lot in psychological research, and we also see a lot of misunderstanding of what these relationships really tell us or can tell us. And so, generally speaking, with correlations, there's three outcomes that we could get. First, we could get a positive correlation, and that means that our two variables change with each other. So as one variable increases, so does the other one. This is what we see here, where we see as one variable is increasing, we see the other variable increasing as well. And we see this positive trend in our data. Then we also have negative correlations, where we see as one variable goes down, the other variable goes up. So this is one area that I think people sometimes get confused about in terms of positive versus negative correlations. The distinction here is that for a negative correlation, we're always going to see this negative slope, but it's when things are changing in opposite directions. So higher values on one variable are associated with lower values on another variable. Whereas in a positive correlation, high values in one are associated with high values in another. And so it doesn't matter the direction, right? So we could also say low values are associated with low values, or high with low. It's really just a matter of, do the variables change in the same direction or in opposite directions? And so positive, they're changing in the same direction. Negative, they're changing in opposite directions. And then, of course, we also have no correlation at all, which is where there's no relationship, no pattern that we observe in our data, and we see just scattered variables that don't show any pattern that we see. And we can see a few different things about the correlations when we kind of break them down. We can see first the direction, which is what I just mentioned, positive or negative, but also the strength of the correlation itself. And that tells us whether it's, well, a strong or a weak correlation as well. So we could have things like strong positive correlations like we see here. We could have something that is maybe still positive in nature, it's still sloped positively, but it's not quite as strong. There's not quite as big of a range in our data. And so these are two ways that we interpret and understand correlations, is through both the direction and the strength that they represent. But they can also be misleading. So one of the big sort of misconceptions often about correlations is that we can interpret causation from them, which we cannot do. So correlation does not equal causation. This is a big sort of thing I would say to ingrain in your brain, right? Correlation does not equal causation. These are two different things. Just because we see this relationship doesn't mean that it is from one variable causing the other one to change. We can see many, many correlations that are strong, are positive, but truly have no direct cause from one variable to the other. And so it's really often a challenge to interpret correlations without putting too much weight into what they're telling you. A great example of this is looking at the rate of ice cream sales and shark attacks. And that historically has a large positive correlation in those two variables. And so does this mean that the more ice cream you buy, the more likely it is you're going to be attacked by a shark because you're buying ice cream? No, it does not. It does not mean that buying ice cream causes you to be attacked by a shark. But instead, what we have are what we call third variables. And these third variables are some other variable that's not being measured that is likely sort of linking these two things together, or likely maybe causing some of what we're seeing in this relationship. And so for that example, the third variable might be temperature. So the hotter it is, the more likely people are going to buy ice cream to cool off, and the more likely they might also be to go to the beach to go swimming and thus get attacked by a shark. And so when it's cold out, people aren't going to the beach, people aren't buying as much ice cream. And so you see those two things appear to be related to one another or are related, but not that one is causing the other one to change. And so if I can leave you with anything, it is to be very wary and cautious in how you interpret correlations, because there could always be some third variable that we aren't thinking about, right? In this example, temperature is pretty easy to identify, but in any correlation, there could be a third variable that we can't identify that might still be a leading cause of the relationship we're seeing. All right, so this is another one. We see this example, same thing with ice cream sales and homicides. Just like I said with the shark attacks, same idea here. Some third variable might be causing this relationship. All right, so that's what I wanted to say about correlations, a little bit of a shorter one there. But next we're going to talk about experiments and kind of contrast these with correlations and see what are some of the pros of using experiments maybe compared to correlations. All right, so we talk about experiments and the experimental method. There's a few things we kind of need to lay the groundwork for and understand here. First off, we often do have hypotheses, right, for experiments, and these are things that we are using and we are testing. But more specifically, experimental designs also use what are called independent and dependent variables. Correlations do not use independent and dependent variables, only experimental designs do. And so what these are basically an independent variable being something that we control, we manipulate, and a dependent variable being something that we observe the outcome of. So these kind of work hand in hand for us to be able to study from the scientific perspective using this experimental method where we test, we control some independent variables, and see how that changes some outcome of our dependent variable. So again, the hypothesis being an important characteristic of this as a starting point where we have some prediction. What do we expect the change from our independent variable to do to our dependent variable? And so with our hypotheses, there are a few things we need to make sure that we keep in mind when we design and put together our predictions or our hypotheses. They should be consistent with our observation, right? So we don't want to just come up with some wacky out there guess as to what we think could happen. We want these to be backed in understanding and knowledge so that we are more likely to see that outcome, more likely to confirm our hypothesis. Generally, they should be simple. So we don't want a hypothesis that says we think X, Y, and Z, and also a little bit of A are all going to be a factor that affect what happens with B, because that's really complicated and hard to test. Instead, we would want to say that, well, we think X affects B in this way. We think Y affects B in this way. And we could test those specific, that's the next one, hypotheses each at a time and identify if they are supported or not. Of course, number 4, they need to be measurable, right? So we need to be able to actually measure them in order to test and confirm or reject those hypotheses. They should establish causality, right? So this is kind of that distinction with correlations and experiments. Our hypotheses for experiments should make sure that they are able to establish this causality, that we can test and show that our independent variable causes a change in our dependent variable. Now we can say that there is a cause in our results. And lastly, they should be falsifiable. And what I mean by falsifiable is just that they can be tested, right? I could have a hypothesis that there is a purple elephant that lives on Pluto. Maybe Pluto's not the best one, but lives galaxies away. And this purple elephant likes to dance on Sundays. And that is my hypothesis, is that he prefers to dance on Sundays than he does on Wednesdays. Well, that's a great hypothesis, but there's no way to test it, right? There is no way, nothing I can do to test that hypothesis. And so there's no way to confirm or deny it. And while that is an extreme, humorous example, in reality, even in our own science and our own research, we need to make sure that our hypotheses are falsifiable, that they could be proven or that they could be shown to not exist in order for us to then provide rationale that they do exist. And so that is a key component here when we're talking about hypotheses. All right, so we talk about experimental variables. We've kind of talked about these already, but again, our independent variable is what we are manipulating, what the experimenter controls or changes. The dependent variable is what the participant does or what the experimenter measures the outcome of. And then we also have what are known as extraneous variables. These are variables that we generally don't want these in our studies, right? We try to avoid them as much as we can, but sometimes they do creep in, and sometimes they are measures that get, sort of observed or measured, even though we don't really want to measure them. And so laboratory studies try to control and eliminate extraneous variables, whereas, say, something like a naturalistic observation, observing someone out in their natural environment, are going to have a lot more extraneous variables that you aren't able to get rid of or aren't able to control. Let's talk now about sample selection. So sample selection is really about selecting who's going to be in our study, right? So how do we select people to be in our research? And there's a few different techniques and ways that we go about doing this. The first one you see here is just simple random. This is the idea that really everybody has an equal chance of being selected to be in the research study. And while on like a global level, this really is not very often the case, or really ever, we can look at populations that are sort of smaller in nature. So we look at all students at UCF, right? We could say that maybe you have a chance of getting an email that says you're invited to participate in this study. And that is a simple selection, simple random selection where random students were selected to receive that email. And that might be a way to use simple random selection in that sort of population specifically. Then we have what's called stratified random sampling, which basically breaks your population into smaller subgroups. So in our example that we just talked about, right, if we look at all the students at UCF, maybe we want to make sure that we are also getting representative samples from each of the different majors or each of the different colleges. And so maybe what you might do is stratify your population into the colleges first, and then randomly sample from within those colleges so that you make sure that you're representing each of those groups out of your larger population. And of course, we have other methods that are non-random sampling, like maybe there's unequal chances. Maybe that's like things like snowball sampling, or ways of just kind of selecting specific people to partake in your research. And then lastly, I want to mention is convenience sampling, which would oftentimes also be non-random, but maybe you just select samples based on convenience or individuals that are easily accessible to be included in your study. And this is often used maybe in tangent with some other methods as well. Now, when we look at these different groups and these different people in our studies, we kind of often break them into two different groups, especially for experimental designs, right? Where we have an experimental group and a control group. And really the main distinction between these two things is that an experimental group has some manipulation put on them. So they're the group that has your independent variable manipulated and changed, and the control group is the one that does not have some manipulation put on them. And so I think what's really interesting here is a lot of the times people think that you always are going to have a control group, and that's not necessarily the case. You could have two experimental groups, each have a different manipulation, and you want to compare those two manipulations to one another. You may also want to compare to a control, but that's not always going to be the case. And so you might see some studies that have control groups and some studies that don't have control groups. It doesn't mean that it was a poorly designed study just because it didn't have a control group. It might just not have needed one in its particular context. We can also talk about placebo groups. So sometimes we use placebo groups here as well in order to basically see if there is a placebo effect, especially in ways or in studies that look at things like maybe medical trials or clinical trials, seeing if the effect of placebo, or basically simply believing that they are in a control group, or participants believing that they are in an experimental group, might be enough for them to see the effects of that experimental group. And so that's really the idea of the placebo here, is that you see effects without the true manipulation, just from participants thinking that they are in the manipulation. And so sometimes this is really important to compare to the true manipulation to see if there really are differences from the actual manipulation that you're trying to measure. So placebo groups, also an important kind of way of looking at this from a design standpoint as well. All right, so that wraps up learning objective 5. We are now going to talk about our last learning objective here, which is where we're going to talk a little bit about sort of how we look at the numbers, how we look at the data, where we'll talk specifically about central tendency, things like variability, and also ways that we kind of describe our data a little bit. All right, so first and foremost, we need to talk about the difference between internal versus external validity. So internal validity is really the idea that whatever it is that we're measuring, whatever variable that we are looking at, if it is internally valid, that means that it measures what it is intending to measure, right? So in this example here, you see mathematics students' grades improved only after space retrieval practice. So in this case, they didn't actually change the difficulty of any given quiz that they were taking. So they did some behavior, and we saw that it did actually work to change their scores. So the scores were internally valid. They were measuring that change based on this spaced retrieval practice that the students did. So internally valid measures are measures that, in fact, do accurately measure what they set out to measure. External validity is the degree to which results can be generalized. So now that you found something that your measure might have identified, if you have external validity, you can take those findings and apply it outside of that specific context that you just measured it in. So in this case, the degree to which maybe these results can be generalized to other people, other times, other settings. So for example, if we found that this spaced retrieval practice helped mathematics students improve their grades, well, can we also see it affect or improve chemistry students' grades in a different semester? Now we're looking at different students, a different time point, and if we see the same results, well, then we would say we have pretty solid external validity as well. Next, we'll talk a little bit about some different ways that we measure what's called central tendency. So just how our data tends to move towards the center. And what I mean by that is we actually see that here, right? So we see central tendency with higher amounts towards the center of our data. And that's really what that means. And so how do we describe this? How do we explain how our data is clustering or pooling around the center? Well, we can do that using a few different methods. The first method is mode, which is just simply the most frequent value. So we would expect, say on this scale, that this is a scale of heights, right? So we see 5'3", 5'5", 5'7", 5'9". We would see out of all of our data that we collected, we would expect that the mode, the most common value, would probably be 5'9". We would see the most participants with that value because it's the highest at our peak. And so the mode often revolves around the center point is what we tend to see in normally distributed data. Then we have the median, which is the unbiased middle value. So maybe our data is skewed slightly to one direction or the other, but the median basically cuts off those endpoints and just counts backwards until we get the actual middle data point. So however many data points are on one side and however many data points are on the other side, we get the actual middle value of all of our data. And then lastly, we have our mean or our average, which again adds up all those values together and divides by the number of values that were assessed. And so each of these may or may not come out to the same value, but they tend to show this idea of central tendency or how much our data is clustering around the center of its distribution. There's other things we can use to describe how our data is distributed. So we have things like range, which shows the entire range from the lowest value to the highest value in our data. If we have a data set with a large range, well, we have a lot of different points, a small starting point and a high ending point with lots of data within it. Variance is just this idea of looking at mathematically the squared deviation scores, or more specifically, or more generally, just how much each score is different from the other scores in your data set. And if there's a lot of difference in your scores, you'd have high levels of variance. And if all your scores are pretty similar to one another, you'd have pretty low variance. And then lastly is standard deviation, which these are standard amounts that deviate from that central point or that central score. And so you can see on this line that each one of these gaps is one standard deviation. And you can see -1, -2, -3 standard deviations away. And you're going to see as we talk here that we see most of our clustering within, most of our data should fall within -1 and +1 standard deviation. And you see most of the data is within that range. Now, one of the things we use in statistics and in how we test our experiments is what's called the 5% rule. And so the idea here is that if our data is falling within some common central tendency, where we have most of the values clustered within that center range of the distribution, well, we're really kind of interested in or looking for what falls outside of that, right? Because that is what tells us something that we are interested in identifying. We want to look for what is unique, what has changed, sort of what is a rare event to have occurred. And so why this really is important is that when we're talking about sort of research and we're talking about our findings, we would expect that if we did nothing, we would just have findings that fall somewhere within that main big distribution curve. And it would be really rare for us to find something in those tail ends of the distribution. But now, if we have some manipulation that we put into the experiment and we find something in those tails, well, it'd be really rare for that to occur naturally. So we make the argument that the reason we see that appear in the tail is because of our manipulation. It's due to what we had some influence on in those values. And so that's really the idea we're looking at here, is when we look at these distributions, we say, okay, if we can find some result inside this range or inside this rare point, well, that was likely due to what we did to manipulate that to happen. Because it's really unlikely that we would find it naturally, because most of the scores fall in this range. And this exactly highlights what I just said, but the idea that when we look at these distributions, we see first and foremost, if we take a split from the center point, we see that, well, half of our data falls on one side and half of our data falls on the other. That's one of the things we tend to look for, is symmetry, or being symmetrical around that mean point. But there are other things we look at as well. Like I said, a lot of the data falling within that +1 to -1 standard deviation. We see much of those values reported there. And so we can also look to see, do we just have one peak in our data? So our data just comes to one peak. Our data comes to one peak. Or maybe we see something where our data looks more like this. Maybe we see a distribution that does this. And we actually see a bimodal distribution. And so we actually have 2 points in our data that are common high points that we're kind of looking at here. So again, when we're looking at our distribution and how to understand our distribution, there are lots of ways that we can kind of pick apart and try to understand what we're seeing here. And so when we apply this 5% rule, when we look at this in terms of standard deviations, we can see that about 1.64 of a standard deviation accounts for 95% of the rest of the data. So what I mean by that is if we draw this line here at -1.64 standard deviations, everything on this side of the line accounts for about 95% of all of our data. and everything on this side of the line accounts for 5% of our data. So that's that 5% rule that we talked about. And so we're looking to see if something is inside that range. Well, it's pretty unlikely that it would have occurred naturally, and instead is likely due to whatever manipulation we placed onto our data. And so if we look at this in terms of height specifically, we would see that the average height of a man being 5'9", we would expect anybody less than -1.64 standard deviations to be a rare height. So anybody 5'6" or less would be a rare or less likely height that we would see. And same thing on the other side, anybody about 6 feet or over, we would also expect to be more rare of a case. All right, so I'll kind of wrap up here by talking about how we use this in research and how statistics kind of play a crucial role when we're trying to investigate and interpret our research, right? And so we do this really to provide some scientific backing, some empirical backing to our findings, and it allows us to have this, what we call statistical significance, or again, the argument that what we are finding is rare without manipulation and thus due to our manipulation. So if we did not do anything, we would not expect to find the finding that we found. And so we make the argument that it is what we have performed, what we have manipulated onto our variables that is the cause of this rare outcome that we're observing. And so we'll kind of wrap up with this for this chapter. Using statistics, kind of talking about how this fits into the methods of psychology and psychological research gets much more complicated. There's a lot more that we can talk about in terms of how this works. But this is just a really sort of introduction to this. And I wanted you to kind of have an idea of some of the terms and some of the things that we talk about in this context. All right.